Welcome to the Mathematics in my channel. Today I am going to solve another interesting integral from 0 to infinity sine of x over x to the n. So in this video I am going to evaluate this integral by using three different methods, and also in solving process we need these formulas: beta function, and here Euler's formula, and here we know Euler's reflection formula. Okay, as a first method I am going to use mass identity of Laplace transform. We know the mass identity here 0 to infinity f of x times g of x dx. So now here integral limit 0 to infinity, and we have product of two functions, so we can use 0 to infinity Laplace transform of f of x times inverse Laplace transform of g of x dx. Okay, this is the mass identity of Laplace transform. So here we have sine of x over x to the n. So I am going to take sine of x as a f of x. So here sine of x, and 1 over x to the n I am going to take as a gx. So gx is equal to 1 over x raised to the n. Now we know Laplace transform of sine of x is equal to 1 over x square plus 1 and also we know inverse Laplace transform of g of x is equal to x to the n minus 1 over n minus 1 factorial. Okay, then our integral from 0 to infinity sine of x over x to the n dx. Now we can use this formula, mass identity. So we can write this is equal to integral from 0 to infinity Laplace transform of f of x. We know 1 over x square plus 1 times, then inverse Laplace transform of g of x. We know x to the n minus 1 over n minus 1 factorial dx. Okay, then we can simplify here n minus 1 factorial. We know n minus 1 factorial is equal to gamma of n, so we can write outside of the integral sign, and here 0 to infinity x to the n minus 1 over x square plus 1 dx. Okay, then I am going to take a substitution. So if we take x square is equal to t, then differentiate. So 2 times x dx is equal to dt. Then we know this is equal to I is equal to 1 over gamma of n integral. Now limit also 0 to infinity. So 0 to infinity. Now here x to the n minus 1, we know x is equal to t to the 1 half. So t to the 1 half times n minus 1 over x square plus 1. We know x square is equal to t. So t plus 1 times now dt. So dx is equal to dt over 2 times x. We know t to the 1 half. Okay, then we can simplify. So here 1 over here 2 we can write outside of the integral sign. So 1 over 2 times gamma of n, and here 0 to infinity. Now t to the 1 half minus times n minus 1, here t to the 1 half. So if we simplify, we will have t to the n over 2 minus 1 over here we have t plus 1. Here t. Now we know this is familiar with us because here this is beta function, so we can write this is equal to 1 over 2 times gamma of n times, instead of this integral we can use beta of mn, beta of n over 2 comma 1 minus n over 2, so we can write it by gamma function. So gamma of n over 2 times gamma of 1 minus n over 2 over gamma of if you take sum of these factors, so we know gamma of 1. Okay, then here 1 over 2 times gamma of n, here gamma of x times gamma of 1 minus x, so we can use Euler's reflection formula. So we know this is equal to pi over sine of pi n over 2, because here n over 2. Now we know this is equal to pi times cosecant of n pi over 2 over 2 times gamma of n. Okay, this is the answer. Okay, then this is first method using mass identity. Now we are going to evaluate by using Euler's formula. So I'm going to take our integral from 0 to infinity sine of x over x to the n, and we know here e to the ix cosine of x plus I times sine of x. So we know here we have sine of x, so we can write sine of x is equal to imaginary part of e to the ix. So we can write now our integral I is equal to imaginary part of integral from 0 to infinity, instead of sine of x, e to the ix over here x to the n dx. Okay, then we can take a substitution. So if we take x is equal to I times u, then differentiate dx is equal to I times du, limit also 0 to infinity. So we can write this is equal to imaginary part of integral from 0 to infinity. Now e to the I times x, so x we know I times u, so I square we know minus 1, so e to the minus u over x to the n, x we know I times u, so I to the n times u to the n, and dx we know I times du. Okay, then imaginary part of, now we know I to the n, here I is a constant, so we can write outside of integral sign I to the 1 minus n, integral from 0 to infinity e to the minus u times here u to the n, so we can write in the numerator u to the minus n. So I am going to rearrange u to the minus n like 1 minus n minus 1 du. Okay, now this is familiar with us because we know this is definition of gamma function. So we can write imaginary part of, now I, here I we know I is equal to e to the I phi over 2, e to the I phi over 2. So we can write this is equal to e to the I pi over 2 times 1 minus n, here gamma of 1 minus n. Okay, then here we should take imaginary part of e to the I phi over 2 times 1 minus n. So we know this is equal to imaginary part sine part. So here we have sine of pi over 2 times 1 minus n times here gamma of 1 minus n. So instead of gamma of 1 minus n, here we can isolate gamma of 1 minus n. We know pi over sorry, pi over gamma of n times sine of pi n, gamma of n times sine of pi n. Okay, then here sine of pi over 2 times 1 minus n, we know this is equal to cosine of pi n over 2. So here pi times cosine of pi n over 2 over here gamma of n times, instead of sine of pi n I am going to use double angle formula. So 2 times sine of pi n over 2 times cosine of pi n over 2. Now we know cosine get cancelled and we have here pi, here sine 1 over sine, we know cosecant, so cosecant pi n over 2 over 2 times gamma of n. Okay, this is the answer, and we solved by using Euler's formula. Okay, then third method, now I am going to use Mellin transform. Okay, this is the third method, and now first of all we know the definition of Mellin transform. F of x is equal to 0 to infinity x to the s minus 1 times f of x dx. Well, then if you take Mellin transform of sine of x, we know this is equal to gamma of s sine of pi s over 2, and Mellin transform of sine of x. In a previous video we found Mellin transform of sine of x. So if you like to watch that video, I will add the link and also make a card. Now we can write our integral sine of 0 to infinity sine of x over x to the n dx is equal to now here Mellin transform of sine of x, gamma of s times sine of pi s over 2. So to convert our integral 0 to infinity sine of x over x to the n like this integral, so here s minus 1, but here x raised to the minus n power, so s minus 1 is equal to minus n. Then we know s is equal to 1 minus n, so we can write our integral is equal to here gamma of s, so instead of s now 1 minus n, so gamma of 1 minus n, here sine of phi s over 2, so sine of pi, now s we know 1 minus n over 2. Okay, then we can simplify. We know gamma of 1 minus n is equal to pi over gamma of n, pi over gamma of n sine of pi n, and here we have cosine of n pi over 2, cosine of n pi over 2. Now we solve pi times cosine of n pi over 2 gamma of n sine of pi times n here in this place. So we know this is equal to pi times cosecant of pi n over 2 over 2 times gamma of n. Well, thank you for watching.